Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at probability formulae, so we can answer questions from exercise 2D. We're going to look at two different formulas here that we can use for Venn diagrams in case we're not quite given enough information to solve a Venn diagram question. So let's have a look at the first formula and see where it comes from. What we're going to do is we're going to set the probability of A, the event A, equal to little a, probability of B equal to B, and we're also going to set the intersection equal to I. And you try and come up with a formula that links A, B and I together. So I will go in the middle, and then if you remember we need to do A minus I to work out this section here because we want the total of that circle to be A, and then obviously the same on the right hand side, B minus I there. If you can't quite remember why you are subtracting I here, just have a look at some previous questions in which we kind of do this but without explicitly saying it's A minus I. What we do is we take the whole probability for the circle, take away the bit that we already know and have what's left over in this section of the circle, in this section of the Venn diagram. So what we're now going to look at is a formula for the probability of A or B. So this is both circles added up together, or all the regions of this Venn diagram added up together apart from the outside. So it's A minus I plus B minus I. Now if we simplify this a little bit, all we're left with is A plus B minus I, and we could effectively use what we've got here to replace the right hand side. We're going to replace the right hand side with probability of A plus probability of B, take away the probability of A and B. So this is our first probability formula then. The probability of A or B is equal to the probability of A plus probability of B, take away the intersection of the two probabilities. So that's our first formula then. Note that for mutually exclusive events, the probability of A and B is equal to 0, so therefore a specific case for mutually exclusive events where there is no intersection between the two circles is it's just a probability of A plus B. Don't remember that one, just remember the big one. Let's have a go at using this in a question here then. So the probability of A and B are two events, so A and B are two events, such that the probability of A is 0.6, probability of B is 0.7, and probability of A or B is 0.9. Find the intersection of the two probabilities, or find the probability of A and B. And what we can do here is just substitute the numbers into the formula. We're going to have 0.9 equals 0.6 plus 0.7 minus what we're trying to find. Move things around a little bit and you get 0.4 as your probability of A and B. So there we are, that's how we can use that first one. Let's have a look at a second one as well. And let's have a look at conditional probability, the probability of B happening given that A happens. That's the B line A one. Will mean we're only using section A. So we're working out here the probability of B happening given that A happens. So if A definitely happens, we know we're working only in the A circle. So therefore the probability of B given that A is true will have a denominator of this whole circle, A minus I and I. And then it's the probability of B, well it's only this section here that it is where B is happening, so I will go on the top there. We want the probability of B to happen, so the B goes on the top there. And simplify what we've got here. And you can obviously see that the i's cancel out on the top, on the bottom here, plus and minus. So it's just I divided by A. So therefore it's just going to be the probability of A and B divided by the probability of A. So this is formula number 2. The probability of B given A is equal to the probability of A and B divided by the probability of A. So as I said, you sort out the denominator first by taking the second one and putting it on the bottom, and then you take both of them and put that on the top. Okay. And what you can do is you can multiply the other side by 8 so it's not a fraction. I actually quite like it in fraction version here. We're going to remember it in the top right in multiplicative form, but I actually prefer it as written as a fraction. Let's have a go at a question here then. The probability of C and D are two events such that the probability of C is 0.2, the probability of D is 0.6, and the probability of C, given that D is true, is 0.3. Find the intersection of C and D, the probability of intersection C and D, and then find the probability of D given that C is true, and then find the probability of C or D. So lots of good opportunities to use our two formulas here. Let's get stuck into the first one, the probability of C and D happening. So what we're looking for here is to use this formula here, the second one that we've just created. The probability of A and B is equal to the probability of A times the probability of B given A is true. Now, what we've got here is we've got a formula with A's and B's in it. We really would like them to have C's and D's in it, so let's just start by replacing A with C and B with D. I think we've probably got this the wrong way around though. We actually know the probability of C given that D is true, so actually I'd quite like them to be the other way around. So what I'll do then is I'll just swap the D's and the C's around. And you can do that with these sorts of questions in this particular case. So the probability of, now do you see this part here, the probability of C and D, this part here is actually going to be the same thing as it. The probability of D and C is the probability of C and D. You've just swapped around how it's phrased, but really this thing here on the left hand side is going to be the answer to this part A here. So let's answer this question then. We know the probability of D, we know the probability of C given that D is true, so let's multiply these two values together and we get 0.18. So that is the probability of D and C happening, which is the same as the probability of C and D happening. We're just phrasing it the other way around. Okay, let's now have a look at the probability of D given that C is true. So same formula we were just using, but let's replace it as we did just. So A replaces C and B replaces D. So let's have a go at probability of D given that C is true. We want to work out this part of the formula here. We know this part and we know this part here, so let's substitute them in and then divide by 0.2 and we get 0.9 as the probability of D given that C is true. Notice here how these are kind of Venn diagram questions. We're not actually using a Venn diagram at all. We're just using the two formulas that we've been given above. The final part, part C, is going to be using the first formula that we were given here. The probability of C or D is true. So let's replace A with C and B with D. And then plug in everything onto the right hand side that we know. We know the probability of C, we know the probability of D, we know the probability of C and D, given that we answered that in part A. And then the answer is 0.62. So there we are. So all of these questions here that we've just done, it didn't actually need us to use a Venn diagram. We could have drawn a Venn diagram with the information that we were given. We didn't need to because we've got our two formulas that are really handy. Have a go at this question here then. Pause the video and try this one out. Right, okay, let's have a go at this question then. I'm just going to write out the formulas that we need to use. It's B given that A. Okay, so let's have a go at part A then. The probability of C and D being true. So we know the probability of C given D is true, C given that D is not true, and the probability of D. Okay, so let's start off with this first one here then. I'm going to use the second of the two formulas that we have just kind of created. Now we know that we've got C given that D is true, so it's definitely going to be that way round that I'm going to want it. And if I have it that way round, then I'm going to want to use the probability of D in the first part here. It doesn't really matter which way around these two are written here because they're both and, or if it was the other way around and it was an or symbol, it wouldn't matter either. So let's work this out. We're going to have 1/4 times 1/3, which is 1/12. So the probability of C and D is 1/12. Find the probability of C or not D. being true. Okay, what I think I might do here now is I might pull in that first formula. The first formula was the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. The only thing is, I still don't know what the probability of C is here. I know the probability of D, I know the probability of C and D, I still don't know the other one. So, what I'll probably have to do, instead of using the first one, I'll use the second one instead. I've got the probability of C given that D is not true, so therefore I'll somehow try and figure out how to use that. The probability of C given that D is not true. This is actually not going to work out the probability of C or not D. This is going to work out the probability of C and not D. So, working out the probability of C and not D, we're going to have the probability of C given that D is not true, and if I'm using this formula right, I need the probability that D is not true. Now, if I know the probability of D is a quarter, I know the probability of not D is 3/4. And then the probability of C given that D is not true, I'm given here as 1/5. So I've now got here, this is 3/20. Right, okay, now that I've got 3/20, I'm feeling like I'm a little bit stuck. I think what I'll do is I'll go to a Venn diagram and see if I can put all the information into this Venn diagram, see what it gives me out. So C and D over here. Now, what do I know? I know the probability of C and D is 1/12. I know the probability of D is 1/4, so that's the same as 3/12, so I need 2/12 left over to go in here. I know the probability of C and not D, well that's this section here actually, that's 3/20. So then actually, I can actually do all of this maths now, can't I? I can do 3 divided by 20 plus 1/4, and that gives me 2/5, so outside here is going to be 3/5. Great, so I've now created my Venn diagram and I can now answer whatever question I want to. The probability of C or not D, so that's going to be 3/20, 1/12, and not D includes this 3/5 out here, so the probability of C or not D is equal to 3/20 plus 1/12 plus 3/5, so that's going to be 10/12, 5/6. Lovely, there we are. Part C then, find the probability of C. Great, I've already got a lot of that work done there. 3 divided by 20 plus 1 divided by 12. That gives me 1/15. No, wait, I've done a plus there. So it's 3/20, so that's 0.15 plus 1/12. That gives me 7/30. So the probability of C is 7/30. The probability of D, the question D, probability of D given that C is true. Well, if I know that C is true, then C will go on the bottom of my fraction. That's going to be 7/30. And then the probability of D, that's going to be 1/12. So it's going to be 7 over 12 times 30. No, that's wrong, isn't it? That's wrong. 1/12 divided by 7/30. Just doing it on my calculator. 5/14. There we are. That's the answer to that one. Part E, find the probability of D is not true, given that C is true. Probability D is not true, given that C is true. Well, if C is still true, that still needs to belong on the denominator, and it's the probability that D is not true. So if I'm working in this C region here, it's going to be 3/20 is the part where D is not true. So I'm going to have on the top of my fraction 3 divided by 20, which is 9/14. There we are. And final question then, part F. Find the probability if D is not true, given that the probability of given that C is not true. So if C is not true, then it's just cross off that one, cross off this one. So it's going to be the combination of these two things here, 2/12 plus 0.6, that's 23/30. So I've added together the region that is not C, and now I need to work out the probability of not D happening. That's 3/5 on the top. So it's going to now be fraction button 3 divided by 5 over 23 divided by 30, which is 18/23. So I kind of got a little bit distracted from using my formulas here. I do like using a Venn diagram where possible, but these two formulas here are really good to help get you started on these types of questions here that involve Venn diagrams and given that probabilities, etc, etc. So have a go at plenty of the questions from exercise 2D, the exam style questions, the problem solving style questions, and ask your teacher for help if you need any. This is quite a fiddly little bit of maths. Hopefully this video made some sense to you. Thanks very much for watching.